Welcome to another Intermediate Algebra video. In this video, we'll start to look at operations with more than one radical, specifically adding and subtracting and multiplying. So our objectives are to add and subtract rational expressions, and then also to multiply radical expressions. Here are the notes that go with this section. The first are our addition notes, so this is for add or subtract. And so the rule basically is if you have like radicals, meaning the same exact index of radical with the same exact stuff inside, variables and everything inside and variables outside, you can combine them together like they were like terms. So we don't see a coefficient on either of these given radicals, but you can assume that there's a coefficient of 1. And so when you add 1 square root of a plus 1 square root of a, they combine to be 2 square root of a. And this is just like you would combine x plus x, which is a 1x plus a 1x, giving you a 2x. A common mistake is to assume that the same radical of the same index but not the same inside pieces can combine together. So it does not, these two do not add together to be the square root of a plus b. They individually can simplify, so don't include that. This is to show you what not to do. And the big note is that these must be like terms with like radicals, meaning everything inside the radical is identical. Every number, every variable, identical. The stuff on the outside only needs to have like terms, meaning like variables. The coefficients can be different, and they'll combine just like they would any other like terms. Then with multiply, as with multiplying in most cases, you can multiply anything together. So we have a square root of x times b square root of y. You can multiply the outside by the outside and the inside by the inside. So a times b, and x times y on the inside. You can think of this just like you would multiplying 2x times 3y. You can multiply those coefficients, a and b. 2 times 3 gives you 6. And then the inside stuff is sort of like variables, x times y. So we get 6xy. Multiplies in a pretty similar way. All right, so let's see some examples. We'll simplify, and again, all variables represent non-negatives. So our first problem, 4 square root of 11 plus 8 square root of 11. The main question you need to ask yourself is, are these like radicals with like terms? They're both square roots, they both have 11 on the inside, and any variable on the outside matches. There is no variable. So these are like terms in the radical world. These combine together and they keep that square root of 11, and the outside pieces combine together. 4 plus 8 is 12. This is very similar to taking 2x and adding 3x. It's tempting to say that that radical 8 has to increase or change in some way, but just like if you added 2x plus 3x, you get 5x. The x remains the same, it's just the coefficients that change. Okay, the next one, we have 5 cube root of 4x. The question, are these like radicals? Well, they both have a cube root, that's good. They both have 4x on the inside, that's good. And they have the same variables on the outside, which are none. So these are like radicals, which means you can combine them. So sort of treat the radical piece as if it was a variable. They need to be completely the same, just like this x and this x need to be the same. This radical and this radical need to be identical. So they combine together. 5 minus 2 gives us 3, cube root of 4x. And you might be wondering, well, can I simplify? There's a 4 underneath that radical. But remember, you can only take a 4 out of a radical if it's a square root. This is a cube root, which means we would need a group of 3. And 4 only breaks down to 2 and 2, which is not enough. But we still do need to attempt to simplify on all these problems. The directions are simplify. All right, the next one, square root of 20 plus 2 square root of 45. So to start out with, these two are not alike. They are both a square root, so that's good, but they are not of the same thing. This is of 20 and this is of 45. So the only other option we have is to simplify them individually. So we can take 20, look for any perfect squares or any pairs in there. 4 times 5, the 4 is 2 times 2, pair of 2's. So the 20, the square root of 20, can simplify to 2 square root of 5. Then the 45, 9 times 5, the 9, 3 times 3. So there's a pair of 3's, which means a 3 comes out. So we already have a 2. A 3 comes out, and then a 5 is left inside. Clean this up. We have 2 square root of 5 plus 6 square root of 5. And now these are like terms. So it's kind of unexpected that you'll start with something and then get like terms, but it can happen here. They don't look alike initially, but after some simplifying, we see they're both a square root of 5. And so since they are alike, then we can add them together. Add their coefficients, 2 and 6, which gives us 8 square root of 5. And we can't simplify the square root of 5 anymore because we already simplified it in the pieces that it came from. So for these problems, it's not a guarantee if it would be better to simplify first, like we did with this problem, and then add, or if we should combine and then simplify. It really depends on the problem. So you just kind of feel it out as you're going along. But simplify means to do everything that you possibly can. All right, and the last one on this page, 4 square root of x plus 5 cube root of x. So are they like radicals? They both have an x on the inside, but one is a square root and one is a cube root. And you can only add together radicals that have the same stuff inside, have the same index, and the same variables on the outside. So this one, there's nothing you can do with it. Not only do they not add together, but neither of them individually simplify. So if this is the problem you're given, you can just recircle it, you can retype that in. However your answer needs to be presented, you present it the same way it was given. All right, let's see a little bit more. Again, simplify, and all variables are non-negative. So we have square root of 27x minus 2 square root of 9x plus square root of 72x. So right off the bat, we see that none of these are alike. So the only option we have is to simplify them and then potentially combine them together. So we have 27, let's start there. That breaks down to 9 and 3. 9 breaks down to 3 and 3. Pair of 3's, so a 3 comes out, leaving inside a 3x. The second one already has a 2 on the outside. That 9 is a perfect square or has a pair of 3's. So a 3 comes out, leaving an x inside. So that one ultimately cleans up to be minus 6 square root of x. And then the last one, the 72, breaks down to 9 times 8. 9 is 3 and 3, 8, 4 and 2, the 4, 2 and 2. So we have a pair of 3's and a pair of 2's. So 2 and a 3 come out, leaving inside a 2x. So plus 6 square root of 2x. Okay, so we simplified each one. Is it possible now to add them together? Are they like radicals? Well, they're all square root, so that's good. But the inside stuff is different. While they all do have an x, they don't have the same coefficient. They need to be completely identical inside the radical. 3x, x, and 2x means there's nothing else you can do with this problem. And so this would be your final answer. A common question based on this final answer is, well, if they don't actually add or subtract, combine anymore, do I have to even simplify them? Yes, the directions say simplify, which means do everything you possibly can. So this would have to be your answer. The only way you could modify this is if you reordered the terms in some way. If you wrote negative 6 root x plus 6 square root of 2x plus 3 square root of 3x. This would also be okay, but there's no reason to change it. When it comes to radicals, there's not really a best way of writing them in a specific order. It doesn't really matter. So this would also be okay, but there's no reason to change it. All right, so those are some add and subtract problems. Sometimes you will get to a place where they combine more, and sometimes you won't. Let's look at some multiply problems. The first one, 3 square root of 10 times 5 square root of 2. Remember, you can multiply any of these together, and it's the outside by outside, inside by inside. So outside and outside are 3 and 5, so the stuff outside the radical is 15. And then inside by inside, 10 times 2 is 20. So we have 15 square root of 20. Continue simplifying by making sure that nothing comes out of this radical. This one clearly doesn't have any add or subtract to it, but it's possible something will come out of that 20. We can separate this to 5 and 4, the 4 to 2 and 2. Pair of 2's, so a 2 comes out. And what's left inside is this 5, ultimately giving us 30 square root of 5. So it's a good distinction to make, to recognize with add subtract, the only way they're going to combine is if they are alike. With multiply, anything goes. Outside by outside, inside by inside. Okay. All right, let's see some more. Simplify, all variables are non-negative. All right, so we have multiplying, but in a bigger way here. So this problem, the first one, square root of 3 times the quantity 5 plus square root of 30, is very similar to a problem like this. 2 plus 3x. We have an x and an x term. They're both kind of radicals. And then the 2. So how would you multiply if this was the given problem? You distribute, right? You distribute the x times the 2, so in this case it'll be the square root of 3 times the 5. Now when you multiply x times 2, what happens? They don't really multiply to change in any way, but they still multiply. It just becomes 2x. So in the same way, square root of 3 times 5 multiplies and becomes 5 square root of 3. And remember, it's just standard practice to write the coefficient piece in front. Okay, the second multiplication would give us plus, so we have plus, the same in both, 3 and then x squared. So your computation's a little different in the radicals in that it's outside by outside, inside by inside. So on this multiplication, we have a 1 square root of 3 times a 1 square root of 30. So on the outside is still a 1, which doesn't need to be written. And on the inside, 3 times 30 is 90. Now, the directions say simplify, which means do everything that you possibly can. So what else is possible? Well, there's addition, so can they combine? They're not like radicals. But maybe if we simplify, they will be. So let's take the 90, break it down, 9 times 10, the 10 is 2 and 5, the 9, 3 and 3. There's a pair of 3's, so this first radical doesn't simplify in any way, but the second one, a 3 comes out and a 10 is left inside. And then you check, okay, now I simplified each one individually, can I combine them together? In this case, the answer is no. It's possible that they will combine, so this is as simplified as you can get it. And again, yes, this is how far you'd need to go with it. And just like the last one, the only thing that can be different is the order of the terms. Okay, the next one. square root of 2x minus 5 times the quantity square root of 2x plus 5. So this is just like having an x plus 2, x minus 3. If I told you to multiply this, what would you do? FOIL, right? The x would get multiplied by each term, then the 2 would get multiplied by each term, and then you'd combine stuff together. So we do exactly the same thing here. First, this square root of 2x will go to both items. So multiply root 2x times root 2x. That gives us the square root of 4x squared. Outside by outside, which is 1 and 1. Inside by inside, 2x times 2x is 4x squared. Then, the square root of 2x times positive 5. This gives us a plus 5 square root of 2x. There we go. Then, the negative 5 gets multiplied by each piece. Negative 5 times square root of 2x. Negative 5 square root of 2x. And negative 5 times positive 5 minus 25. All right, so continue on as you would normally. What happens next? After you would FOIL here, maybe you try to combine like terms. Maybe it would simplify in some other way. For our problem, the first thing you might notice is that these middle terms, 5 root 2x and negative 5 root 2x, they are the same and they in fact cancel each other out. It's the plus version and the minus version. So those are gone. That's one way this simplifies. That doesn't always happen. In fact, these two have a special relationship when they multiply and the middle two terms cancel out. Specifically when they're the same binomial with plus and minus, they're called conjugates of each other. And we'll see that in a future video. It'll be helpful in a future video. But to continue simplifying this, the square root of 4x squared can be simplified. Square root of 4 is 2. Square root of x squared is x. Then we have 2x minus 25. And those are not like terms, so there's nothing else you can do. This is what it simplifies to. Hard to imagine looking at this set of binomials with the radicals and having it crunch down to 2x minus 25. But it does. Okay, next one. We have some fractions involved here, but they're not too intense, I promise. We have the square root of 28 over x squared plus the square root of 7 over x. There's a lot of ways you could start this problem. I'm going to first start by using the quotient rule to separate these two. So I'll have square root of 28 over square root of x squared. The second fraction already is separated, so there's no need to do anything there. Now let's look at simplifying each radical individually. The first one we have is a 28 under a radical. 4 times 7. 4 becomes 2 times 2. There's a pair of 2's. So this simplifies to 2 root 7 in the numerator. In the denominator, square root of x squared, 2 x's, we need a pair. So one pair comes out. And nothing's left inside. In the second fraction, square root of 7 can't be simplified any further, and denominator of x can't be simplified any further. Now, the next goal would be to add these together. In order to add them together, remember, we need like fractions, meaning they have the same denominator, but the radicals are involved, so we also need like radicals. Now, they are the same, so we can most definitely pull them together into one fraction, but do their numerators combine? 2 root 7 and root 7. They're both square roots, and they both have 7 on the inside, so you can combine them together. Remember, the coefficient on this square root of 7 would be a 1, so when they combine, we'd have 3 square root of 7 all over x as our final answer. Okay. let's do some practice with these. Pause the video, go through the add, subtract, and multiply problems, and then we'll go through them together in just a moment. Okay, first problem, square root of 24. These are not like radicals, so we can't combine them together. So we'll attempt to simplify. 24 breaks down to 6 and 4, 6 to 2 and 3, 4, 2 and 2. So there's a pair of 2's. 2 comes out, leaving a 6 inside. The second problem, 54. Let's see if anything comes out of there. We have a 9 and a 6. 6 is 2 and 3. 9 is 3 and 3. Pair of 3's. So a 3 comes out and multiplies by the 3 that already sits there. A 6 is left inside. So we have 2 square root of 6 plus 9 square root of 6. And now these are like terms and can combine together to give 11 square root of 6. All right, let's go with the subtraction problem next. We have square root of 75x minus 3 square root of 27x plus square root of 12x. Currently, none of them are alike, so let's simplify and see if they get to that place. The 75 breaks down to 3 and 25. 25 to 5 and 5. So we have 5 square root of 3x. The second one already has a 3 on the outside. 27 goes down to 9 and 3. 9 to 3 and 3, so another 3 comes out, and inside is left a 3x. So the second piece will ultimately clean up to be minus 9 square root of 3x. And then the last piece, the 12, breaks down to 4 and 3, the 4 to 2 and 2. So a 2 comes out, leaving you with a 3x. And then check, okay, now that I've simplified them, can I combine them? In fact, they are all like terms, so they'll combine together. The first two, you can do them all three at once. I'm just going to do 2 at a time. The first two combine to be negative 4 square root of 3x. And then these two terms combine to be negative 2 square root of 3x. All right, so there's the add subtract problems. Let's look at multiply. We have 2 binomials, which means we'll have to FOIL. So first, the 3z will get distributed, 3 square root of z times 2 square root of z gives us 6 square root of z squared. Then 3 root z times 3 is a plus 9 square root of z. Then we'll multiply the negative 4 by everything. Negative 4 times 2 root z is negative 8 square root of z, and negative 4 times 3 is negative 12. Continue simplifying. You can do them in a different order, it's fine. You can do them all at once, in fact. The first piece, the square root of z squared, turns into just a z, so this becomes 6z. The middle two terms are like positive 9 root z and negative 8 root z, so they combine together to be a plus 1 square root of z. And then the negative 12 just sits at the end. Once we get here, there's nothing else we can do with these pieces, so this is your final answer. And again, in a different order would be fine. All right, the last one, square root of 6 minus 3 quantity squared. Remember what quantity squared means. It means that exact thing multiplied by itself. So it's not quite as simple as just giving that square to each item inside. If it was multiplication inside, that would be the case. But since we have subtraction, no good. So the first thing, and you really kind of have to write this out, is to show what's actually happening. Once we see the problem written in this format, we know, okay, it's going to follow exactly the same process as the last one. So let's go with a different color. We can distribute first that square root of 6. So we have root 6 times root 6 is square root of 36 minus 3 square root of 6. Then we'll distribute the negative 3 minus 3 square root of 6 and then plus 9. The first piece, the square root of 36, turns into a 6. The middle two terms combine to be minus 6 square root of 6. That plus 9 gets tacked on to the end. And there's one difference from this one to the previous one. Here, we can do a little bit more. The 6 and the 9 are both just numbers. You can combine those together. 6 plus 9 gives you 15 minus 6 root 6. Or if you wrote it in the other order, negative 6 root 6 plus 15, that would also be perfectly fine. There's no rhyme or reason on writing it one way or the other. So you have two different possibilities here. Okay. All right, so that's a look at our addition, subtraction, and multiplication with radicals. I'll see you soon for another video.